Okay. Actually, all we're doing today is building one component. It's this, again, it's separate, it's this thing. Call it the subplate locator, or, subplate locator. We'll think of the name for a second. And it's one of those things where, we have to think about the overall task. We're using this assembly to hold the milling fixture. We talked about it a lot already. Or hold the milling, I should say. We're using these fixtures, the assembly fixtures, to hold the workpiece, which we're gonna mill. And most of it's being held in place by little buttons, rest buttons. You can think of them as pins. Most of the nomenclature in the textbook calls it a type of pin, but the parts that I'm using from the previous class, I'm using the same part numbers and everything, so they were called rest buttons. That's these guys. Okay. So we talked a little bit about where things were positioned and whatnot, so I'm going to go into that a little more. You're also going to make a modification to the base plate, because we did, what we did last time was we made these angle brackets, angle locator brackets. We made one. You can see in the picture we're going to use it 3 times. And we made the base plate, and we kind of figured out where we needed some holes in the angle locator bracket to firmly secure it, make sure it was enough thickness there, and all those good things, right? There's a couple of dowel pins on each one to help align it, and then there's a couple of cap screws, right, socket head cap screws to hold it on there. And the holes on this bracket were in a certain configuration. We made corresponding holes in the plate, and because we're using the same bracket 3 times, that whatever that whole configuration on the plate was, we needed exactly the same configuration here and here. We did that, I'm talking about what we did last week. And we did it using pattern, maybe a new way to use pattern that you might not be familiar with, where you start with a relative location from a CSIS, and you go to another CSIS to line it up the same way relative to that other CSIS. The way it was relative to the first CSIS, the way it's going to be relative to the second and third CSIS. I'm going to use. Well, it just so you see, we're going to do the same thing over here. So towards the end of the assignment, we're going to make 2 more sets of the same holes. Okay. So we're going to make that green thing back there. Okay. We talked about before how there's that 3-2-1 methodology, right? We're holding down the workpiece on a plane using 3 of those rest buttons. There's one there. There's one over here. This is below that. This rest button, these are below the workpiece. That rest button and that one. And we talked a little bit about how you're supposed to space them out. There's a little bit of leeway. You can move them one way or the other. You try to keep them out, spread out as much as you can, but if you spread them out too close to the ends, then the middle of the part might, the force of the milling might make it sag in the middle. So you got to take all that stuff into consideration. So we calculated, there should be a rest button here on the bottom and a rest button there. And then you can see they're kind of centered. There's 3, like I said. Those 2 and this one. But this one, we don't have any bracket over here yet, assuming we didn't make that green part yet. Okay? So, yeah, that rest button's going to be on that angle bracket. This rest button's going to be on that angle bracket. You can already see, well, why do we have this angle bracket? Because there's no rest button on the bottom of that. Right? There's nothing under here holding up the part. But we do need 2 points on this side, so we're using that angle bracket here. This angle bracket, the only purpose of it was to hold that rest button. This guy, it's used to hold 2 of them, one on the side and one underneath, right? Same thing with this one, okay? But to make that 3rd button over here, well, we need something else to support it. So you might think, well, why don't we just make 2 more of these, or bring in 2 more instances over here, okay? Well, for the rest button, that means we would need one right there. And we did kind of calculate, it should be right about there, whatever distance that is from the end of the plate. But if I use an angle bracket, these angle brackets, they have this upper leg part of it, or whatever you want to call it. It's the vertical wall. And if I try to do that over here, the vertical wall would crash through this thing, which we briefly talked about, right? That's the lever arm that's going to act as the clamp. And we know it's going to be there, right? So we can't use an angle bracket because that vertical wall would be in the way. So in essence, that's why we had to make a different kind of a bracket, just to hold that rest button there, okay? And I want to say this, I was thinking about this when I was going through my demo one I had before. You know, we're doing this in sort of a series, but you don't really, you know, when you're planning this stuff out, this whole job, it doesn't always run step A to step B to step C, you know. Really, I would have, or whoever did this would have thought about the way they already know to make these. They would have thought about, yes, we're gonna have pins, and yes, we're gonna have this clamp. Right up front, they would have started thinking about how we're gonna clamp it. So even though we haven't made this yet, we're gonna make this next week. Even though we haven't made it yet, it's something we would have been considering this whole time, right? Even in the beginning. Because we have to figure some of that out. We have to think about this guy right now, even though all we're making is the green thing. We gotta think about some other stuff too. So it's like it's a whole process in your head where you're going back and forth. Well, I need this here, but if I need that there, then I'm gonna also have this on the other side, and I gotta make room for that. You know what I mean? It's back and forth all the time. When I'm writing up the instructions, I don't wanna bounce around so much. So, anyway, we need this green bracket, but we don't want it to have the wall, so we had to make a separate one that just had the base, okay? And actually, while I'm talking about it, it really does have to be the same height as this one, because the rest pins that we're using, those pins, they're all a 1/2 inch. And I want all 3 of those pins supporting the workpiece to all be at the same spot where they touch. I want this to be level. I suppose there could be instances where it didn't, but I want them to be level. So I need all these 3 buttons to rest at the same plane on the top. So that means, right, whatever's holding it here has to be the same height as whatever's holding this one and that one. So the bottom half, or the main thickness of our new bracket we're gonna make, this was 19 mils, that's gonna be 19 mils. So that helps us with the calculation there. We also would think about, well, how would I hold that onto the plate? And well, because all we're using it for is that button, you know, you should always be thinking, well, can I reuse the same stuff? In other words, can we kind of use the same stock that we used for this? Remember, these guys were made from a 50 millimeter by 54 millimeter stock, and we just cut it to the right size, right? You know, we could probably do the same thing there. If it works over here for this rest button, it'll work over here. So that gives us kind of the outline shape. 50 going across this way, 54 going that way. And since it's the same size, you know, remember we even talked about this. I want to have a couple of a couple of socket head cap screws and space where they are, which we sort of talked about. What would be the best place to put those? We went through some calculations, not a whole lot. A lot of that's based on your experience. And then we're going to have those pins, and you know, we just decided that's the perfect place to put them, to arrange it. Since this is the same overall shape, we'll just use the same pattern here, okay, because we can. And we don't get into it too much in this exercise, but when you're drilling these holes into the plate, they would use something called a jig, most likely. And a jig would be maybe a tool that lines up the drill bits so that it makes those 4 holes. Well, there's 2 threaded holes and 2 holes for pins, but it makes those holes following this jig. And if we're going to make those holes the same way, we can use the same jig. If we're going to make those the same way, we can use the same jig. So if we make all of these with the same hole configuration, that saves us from having to have multiple jigs to make those holes. And that's the kind of stuff you're supposed to think about, right? And again, a jig is something that guides a tool, like a drill, when it's drilling into something like a plate, okay? So with all that being said, then we know pretty much that green part is basically this guy without the upper piece, right? So that's sliced off with the same holes and everything. Of course, I made it green, and the other one is yellow. Colors are just made easier with the stickers, that's all. In real life, it'd be made out of the same material. So that kind of determines that one. But we actually have 2 of them here because, again, thinking ahead, we're also going to clamp this, right? And we know a little bit about clamps because we've done them before. I know we haven't done a class, but and we'll talk about this in a couple minutes too for another reason. But that's basically like an inch stock. So this width of this arm here is an inch. Basically, because we have that, we can use that too for an inch. And typically, the one we want to use for enough strength and everything is 16 millimeters this way. Okay, and it has what I reference this as the inch. because the way it's gonna work, let me do this, since I have it here, I like showing this off. That would be, I think that one. I'm gonna delete that. Strange. Just to say, show you, it's a hinge, it's gonna do that, see that? So that screw right here, that's called a shoulder screw. That's gonna screw through this part, this lever arm, into another one of those green things. So that's another reason we need that green thing. And even then, when we think about it, can we use the same thing over here? My thought is, we know a little bit about making these. We know that there's this lever arm, and they usually have a shaft over here. And I'm even going to take it a step further. We know that this is going to get welded on this little piece right here. It's called a weldment. And we're saying, just for the sake of this assignment, that's like 12.7 or 12.5 mils, that little thing right there. It's 19 mil diameter, but the length of that is 12.5. That'll come into play in a minute. But that's our typical shape, right? So that information helps us to figure out one more thing we need to use, or we need to add to the green subplate, right? Yeah, we need the holes like we had before, because we're gonna have, like I said, actually I'm gonna make this guy translucent for my demo. So I'm gonna go and make, let's go to view real quick, go to edit object display, I'll take that guy, make it translucent. More or less through it. Anyway, so you can see better, this is what's going on underneath. So yeah, as far as this, again, especially with the one with the rest button, yeah, we got the same hole configuration. Can we even use that again over here? Right, we don't need a rest button over here. We have the hole for it, but we're not gonna need a rest button over there. That's not even workpiece. But we do need this hinge over here, and we're gonna have to calculate this, but it's pretty close to being, that height at 19 mils, that almost would work, just to set this on, I said that, we already know that's 12.5 mils and that's 16. So that can sit on the top of that, maybe, and be the right height for what we need right here. I'm gonna come back to that. Well, it turns out it's a little bit off, that's why we have to put a recess in there. But more or less, knowing that, yeah, we can put a recess in there, we have to. That way we can even use the same template, the same jig to make that piece. We only have to make one of those, and just use it twice. Well, we have to make two, but it's using the same template, the same jig, all right? So, make a long story short, we just make one of those with the same holes we had before in the other one, plus a new thing, recess. So we just gotta figure out where is the middle of that recess, because it's a hole, it's gonna be actually a counterbore hole. And that's actually gonna be the counterbore height, which we have to calculate. And then how far is it from the back of this part, all right? So, I'm actually going through all the steps that you're gonna do. I'm just showing it to you out here and talking instead of reading it through, because I have it all written out here, right? Okay, as you said, one subplate's gonna be used for a rest button. The other one's gonna be used as a place to set the hinge, or that little shaft on the bottom of the lever arm, which is gonna be the hinge. So that's why we need these two plates. So because one has to have a hole for this, and one has to have a recess for that, we're gonna use almost the same information, except we're gonna add a recess to it, and we won't have that upper wall. Okay? So then I have you create it, except this one is just, you vertical distance of 19 mils, because that's overall thickness of the part. I have you put 4 chamfers on it. Then you make the holes exactly like you did on the yellow part, the angle bracket, right? So I don't give you all of the point information for the sketches, but you can go back to exercise 1. It's exactly the same. And you're making exactly those same holes, okay? Then it says the only thing that we got left is that recess, right? So here's how I go about it. We got to figure out 2 things, like I said. What's the depth of the recess? And where's the center of it going to be? I don't care over here, because there's a recess in the green plate here, but we're not doing anything with that recess. The only reason we're using this plate, I said this already, was to put a rest button right there. But on this side, we're going to use it for that recess for the bracket, right? What do I talk about first? Actually, the first thing I talk about is the depth of the recess. It doesn't really matter what order I talk about these. Okay, so this part. Remember, one of the main things we got to worry about is the part, the workpiece. workpiece has to be a little, at least slightly above all the stuff around it. If I look at it right on edge, might be kind of hard to see because it's dim. But see how this is kind of like blue right here, this little guy? That's the lever arm clamp. The red behind it is the workpiece. And it's just slightly below, but it's below it. And everything should be below it, right? Because if the milling tool comes across there, we want all this stuff to be a little bit out of the way. So we have to make sure that's below this. Again, this is the top of the, right here where my cursor is the top of that lever arm. That's the top of the workpiece, okay? So that's gonna play into how deep this is, okay? So I already kind of told you this, and I have it all written down. This is 16 mils. So ultimately what I want, what I want is the plate plus the height of the plate, 19 mils, plus the height of this. The combined height has to be a little bit less than that, right, to keep it below. So what do we got? This is 19, and I said this is 16 right here. And then I also said, just because we could have done all kinds of calculations, but I just said, no, we're gonna use a weldment that is 12 and a half in length, right there. So if that's 12 and a half and that's 16, and I add those together, 12 and a half and 16, it's 28 and a half, right? 28 and a half, I think. Yeah, 28 and a half, and this is 19. So 19 and 28 and a half is 47 and a half. Yeah, 47 and a half. Okay, and you can measure this if you want. This guy, from here, from the top of this down to there, I have it for you. I already did the measurement. It's 46.7. If you want to measure, you can. So the height from here to that plate is 46.7. We just want it to be below that. So basically, we say we can use a round number. We can, if we can make it easy on ourselves, why not? Even being 0.7 mils below it is fine. So, but by saying that, if that's 46.7, we want it 0.7 below it is fine. That means the top of this can be 46, right? That could be 46. That's a little bit below the top. So how do I make this overall 46? Well, I already kind of told you. This is 28 and a half. That's 19. That's too much. That's 47 and a half. From there to the plate, 47 and a half. It needs to be 46, because that's what we said. I want this to be 46. So I felt like I had to maybe do a little bit of work, all right? I don't want to give you all the answers, so it's pretty simple, but I said if it's supposed to be 46 all the way to the top, and right now it's 47 and a half, the way we fix that is we take this shaft and we pull it down a little bit into a recess that gets us from 47 and a half down to 46. So I don't have it anywhere in here, I say it, I mean, it's very obvious. You subtract 46 from 47 and a half. You guys can use your calculator if you want. You know, it's pretty simple, but, I mean, that's the thought process you're gonna use. So, I just tell you, mark down that number, and you're gonna use that when we make the C-bore hole later, right? That will be the C-bore shaft right there, right? And then the other thing, the only other thing we still have to calculate, like I said, is, all right, where's the center of that hole? If you look at it from above, like so, right? We can calculate this, and this is, again, I just sort of said, we know this because we kind of already had this in mind how we're gonna make this. Right? I said it's 1 inch across, but that's actually not critical for what I'm trying to show. What I have as a measurement, just because of the engineering of this thing, this wall right here on the arm, it is, because I measured it, you can measure it if you want, it's 6.5 mils from the center line, where that screw goes. And where that screw, the center line of that screw, that's where the hole's gonna be, on the sub-bracket, right, sub-plate. So we're trying to calculate, well, where is this hole supposed to be on this guy, right? Well, so we gotta do a little bit of math. So that's 6.5 mils. From this face right here, of the arm, of the lever arm, that face to the center is 6.5 mils. Okay. We already know what this is, right? That's one of those rest buttons. Okay. How long is that rest button? Like we said it a bunch of times, it's half an inch, right? What's a half an inch? 12.7 mils. So from this wall of the part, it's touching the rest button, to here is 12.7 right there. And then we already said the center line is 6.5 more. So that's 6.5 and 12.7. That's 19.2. So the distance from the end of our workpiece to where the center of that hole is gonna be is 19.2 mils. 0.2 mils is kinda tiny. And one of the things we didn't really talk about too much is the workpiece is like a casting, so it's gonna be a little bit rough. There's a little bit of tolerance. 0.2 mils might be meaningless. You know what I mean? That part, if we bring in a casting, it's not gonna be exactly whatever the dimensions are, because it's gotta be built, right? It's casting, they're never perfect. So we'll just round it off to 19. So what do we got? From here to here is 19, okay? Well, what I need to know is, from here to here is 19, then how far is it from here to, we're really to the back of the part, because we're making a hole on this part, right? Well, we also, I didn't say this right now, but we can assume this. I want the back of this green part to be flush with the back of the plate, right? So really, the back of the plate is the same as the back of the, the back of the sump plate is the same as the back of the base plate. So really, I need to know how far am I coming off the base plate this way to end up right there, to end up 19 mils from here. Well, I also give you this calculation. From the part, where all these measurements start, from the part to there, it's basically 27.5 mils. So, 27.5 mils this way, I need to come back to where it's 19 mils. So again, I don't give you the number, I got a little question mark there. But I do say it like this. The length is 27.5, and the distance between the other two is 19. The required distance is where you calculate by subtracting the latter from the former. So 27.5 minus 19. I don't tell you the answer. You gotta guess. Again, you can use your calculator. You don't have to. You probably do it when you get to. Right? But again, it's the thought process. How do we figure it out? It's called working with build up and everything. How far does everything go from this and that? You know, it's all getting accumulated, so you're gonna get the right numbers. So with that information, you're gonna make in your part, you're gonna make a counterbore hole, right? And we know this isn't my part. This is from a long time ago. But the counterbore hole is that one. Okay. If you go into the sketch, I don't want to go into the sketch because that'll tell you kind of how well. Actually, whoever did this part, I didn't do this one. They measured it from the other holes. But you know that the length of the part is 54 mils that way. So what I did is I just basically I measured for that point right there. I mean, I kept saying we got to figure how far it is from the back end there, right? Well, you also could measure from the front, because if you have the ceases up in the front, you can use that, because that's 54 minus whatever we calculated, and that'll get you that point, right? As far as this direction, where's the middle of that counterbore hole? Well, that part's 50 mils. We want it exactly in the middle. So I'll give that one away. It's 25 mils from the end, right? So the depth here, or the distance from here to here, I'm not going to tell you. It tells you pretty much. From here to there, it's 25 mils. Okay? It's a counterbore hole. So the counterbore depth, I should go back in there. The counterbore depth, I'm giving it away. I didn't want you to see that. I just gave you the answer now. So that counterbore depth that you calculated before, that's right there. Okay. So that's how you make the hole, and you do make the hole go through the part. However, there's one extra thing we got to do here. A counterbore hole, if you remember, if you just go to the hole command and you have a counterbore, there's no threads here, right? This isn't a threaded hole. So the counterbore hole by itself, well, it is for an M10. It's going to be used for an M10 shoulder screw. So the screw that goes into it, and it does screw in it, so there's supposed to be threads there. But it's an M10. Okay? I don't know if you remember from some of the charts we looked at before, but an M10 hole, there's a the tap size, tap drill size. Basically, it's supposed to be like 8.5. Okay? For a 10 mil screw. So that's why the counterbore hole, it says, make it an 8.5 hole diameter. Remember, the hole diameter is the small main diameter. counter bore is the big one. So for an M10 screw, that will be threaded, it's not threaded right now, but it's gonna be, we're making it as if it was the thread tap size, which is 8.5. Again, that's kind of a standard. It tells you that, right? But because it's not threaded, we still wanna represent those threads in NX. In NX, we do have the ability, if you go to the more button here, I think we might have done this last time. In the detail feature, there's something called a thread. It's just a thread, it's not a hole, it's a thread. You need to have a hole there first to put threads on. And we're using it here because, again, the counter bore hole, it doesn't come with threads, so there's no call out of threads. We kind of faked it saying, well, yeah, the hole is 8.5. But we want, actually, and it's really for the drawings, we want to have something here that does call out holes, threads. And when you show it on the drawing, we really haven't done it much, but what other ways to dimension a hole in a drawing? I didn't do it in my assignments. But you can actually have all the information of the threaded hole by pointing to those threads. You can actually see them right here, those little blue lines. Okay, that's a symbolic thread. That didn't come with the counter bore, but we made that later. Okay, and you can call that out in the drawing. It actually shows up on the drawing. You see the little dashed lines indicating the threads. But anyway, what you do is a symbolic thread, and it actually says pick the cylinder. So you actually pick that cylinder. And because we made it 8.5, we kind of faked it in. Okay. I want to use the information from a thread table. The manual just means, well, I'm just going to type in some numbers. No, let's use the thread table, it's standard. We're using the metric course like we talked about before, right? It already knows the cylinder diameter is 8.5. Now, of course, what's the thread size? Well, what's the screw we're using? It's an M10. It doesn't, in the instructions I tell you M10 by 1.5. In the parts that you're going to download that I got from earlier, I should have renamed it, but I didn't. It just says M10, but it doesn't say times 1.5. That times, remember what the times mean when you see a screw, it says M10 times something? That's the pitch of the threads. So that doesn't really come into play here either. But if you have it set to M10 by 1.5, then we're telling it the size of the screw. The cylinder diameter is saying, well, we're putting symbolic threads in there. And, you know, the tap size for that is 8.5. And down there, that's what I'm looking for. See down there? When I said M10 by 1.5, that's the standards. That's using the thread table. It says, well, that's a tap drill of 8.5. That's why we made the counter bore hole 8.5, to pretend it was exactly the right size that the thread hole should be. Does that make sense? Kind of what we did it. Now, it is a symbolic thread, so you want actually some threads in there. You can actually make a detailed thread, which it actually looks like threads. It's like putting a spiral in a solid. It actually takes a lot of math. We don't really need that in our design. It shows up on the drawing. You got the information on the drawing. It just adds a lot more math size to a file if you put a bunch of threads in there. You could try it if you want. It's kind of cool because you actually see threads. But we don't need that. So symbolic just means we're going to have that symbol in there. The part itself will know, yep, there's threads there, right? Now, I already have a threaded hole. I'm actually in the middle of creating a new one, and it's telling me the threads overlap, so yeah, that makes sense. How can I put one there that's already there, right? Actually, this part was done a long time ago before NX 2212. So that's the symbolic thread that used to look like. That's what the dialogue used to look like. But anyway, so that's what we have to do. Actually, we have to put symbolic threads in there because the counter bore hole doesn't have threads in its own dialogue. Okay. Then the last thing you're going to do, well, one of the last things is to go back to our old friend here. We've got this plate. Let me I'll open up one that I made more recent. That was some of this stuff. This guy. Okay. Because conveniently, we have to make two more sets of holes, we have to make two more sets of holes for those two subplates. And I'm showing here this is the absolute origin. This was the origin we made for the first set of holes, after we made the first set of holes. And then we lined up a CSIS with that. And then I had two more CSIS over here when we made the other two holes. We went, a general pattern from here, from here to there and there. So the orientation here is the same orientation there. We're just doing that two more times, okay? So what you have to do, and it even gives you all this information. I want this set of holes, well, essentially I want that green, one of the green subplates. I want it flush on this side. So I know the hole, or the middle of the bracket here, that's 50 mils this way, so the middle of it's at 25. So you make a CSIS, 25 mils from this. So you might have to measure from there to there. You know, and I do want you to, you know, when you make this CSIS, I guess I'll double click on it. When you make the CSIS, I want you to do the offset CSIS from an existing one. And like we did before, I want this to kind of be the main one. All our other hole CSISs come from this one. So starting here, we have to go that way, a certain distance. Actually, the X is going that way first. So that plate was 6 inches, so you go 3 inches that way in the X, right? And then in the Y direction, the overall part, if you measure it, must be 266.7, because that's what I typed in, minus 25. So the Y direction is this way. So it comes back. So that ends up being in the middle of where that green bracket would be. And then remember, I want the set of holes to be like this, but rotated over here. So make sure the Y vector, the way the Y vector is pointing here, is pointing into the holes like that. You want it to be the same way here. The Y vector is pointing into where the holes are there, right? Corresponding to this, corresponding. So that's one of them. And then the other one, just, we could get into calculations about how far it should be from there to there. But ultimately, we just really wanted that. It's all about that rest button. And for that rest button to be the same as that rest button going straight across, I think that was 90. Actually, no, it was 90. It was 90. It turns out to be 90 from this. I think 90 from the middle of this one. Yeah, 90 from this one. Okay. It's in the instructions. So if you go here and I look at this one, I'm kind of giving this away too. But, so yeah, that second CSIS for the second subplate is going to hold the rest button right there. It's 3 inches that way, 76.2. But this one is 266.7 minus 115. How did I come up with that? Well, 267.6.7 gets us to the end, but it's 25 to there and then 90 more to there. So that's why I did minus 115. Okay. Once you got those two CSIS entities, then you make our friend the general pattern using coordinate system. The from CSIS was this one. Remember, you got to be a little bit careful picking it. Change this to inferred, and then make sure you grab a CSIS. But then when you go to the two, it's easy. It does grab CSIS all the way. Just pick those two and it reproduces those holes. So then, so you're going to do that. So you made the green part. You made a couple more sets of holes on the plate, and then you're going to do our good friend a component drawing, just of the green part. I don't have you do a drawing of the plate. So you know you're gonna bring in the part. I mean the template, component template drawing, rename it 3003 DWG because we're doing a drawing of the part, the green part, which is 3003 model. You're gonna fill out the title block, some, that information. You're gonna make 3 views. Here's a close-up of the top view right here. Right, some call-outs, some notes, some dimensions. Note that the 3, or the main dimensions, the overall length of the part, width of the part, those are the ones that show dual dimensions. Below it, there's inches. And actually, same thing here, because that's the other main thing, right? There's length, width, and height. So the ones that are the main shape, we do the dual dimensions. All the other ones, you turn off dual dimensions. Gotta go to drafting preferences and do that, right? The only other thing, I don't think I talked about this before, but I got a couple of call outs here. One, it says, for example, right there, diameter 22.0 spot face. Okay, and this one says for 8, so diameter 8 through dollar. Okay, so I don't know if I told you how to get those diameter symbols on there, so you just open up the drawing. It's already got them on it, but just, I don't remember if I talked about this or not, but if you go to make a note, right, in this window, when you're typing things in, if you need a diameter symbol, I don't know if you remember this, you can actually, I think I did put this in one of the instructions. Right where your cursor is that you're gonna type, the text input, right click, and there's different fonts. Right over here are some symbols. And my diameter is right there. I don't know if it's always right there. It might have been that I went in there and found it, and these are recents. If it's not right there, you can go down here to more symbols, and there's all kinds of symbols. And it's usually on the first one, drafting symbols. But you can actually just, again, right click there, go there, pick the diameter symbol, and it puts it right on your notes. All right, that's how
Are
you.
you also doing, what is it, Alt 216?
I'll do 1/6.
If you hold the Alt button and then hit 216, wouldn't that also put the diameter?
How did you know that? Did you take a GAT class? Did you? I mean, that's probably, the people that would know that probably took GAT classes or graduate classes. I don't remember stuff like that. I don't do it enough to remember those little, and I almost never teach using hotkeys like that, because there's so many of them, I don't remember half of them anyway. If you do this a lot, you will probably learn it. If you take GD&T classes and formal drafting classes, you'll learn that kind of stuff. You know what, since you said it, where would you do it? Like, up here?
Yeah, just in there, you just hold the Alt button on the right side with the numbers, you hit, so you hold Alt and then hit 0216.
0. Oh, yeah.
Oh, cool.
1/6. I knew that, I just wanted to see if it. I didn't know that. And since you said that, there's a ton of other things that are shortcuts for stuff you're doing, but, yeah, this isn't really good. Maybe you can come up and do it. Well, it's good to know. And actually, that's it, that's all I was gonna talk about. So it was a good way to end it, by you showing me up. That's all I was gonna remember now. So, anyway, then, so, you'll make the drawing, you'll make the read part, and you'll edit the plate. So you'll turn in those 3 things. Okay? Next week, we're actually make that lever arm clamping feature. And assemble everything, we'll give you all the rest of the parts in a compressed file, assemble everything.